Hello, Accelerated Math 7-8 students. We are in Module 10 and starting Lesson 13. Module 10, Lesson 13 is called Changing Scales, and we can find that on page 64 of my comp book. Changing Scales. Oops, sorry. All right, so changing scales. It means exactly what it says. We're changing scales. So that means that we might have more than one scale factor that we're moving around or that we're changing. Our goal for today. Today we will learn how to determine the scale factor from one drawing to another. So you're going to be given the drawing and your job is to find the scale factor. The question that I want you to be thinking about is, can you use a ratio to determine the scale factor? Okay, hopefully you all can answer that already. Things to remember. It's kind of a long list, so I'm just going to show it all to you so that we can talk about it and then we'll practice one. So things to remember. A scale factor tells what kind of scale drawing is being produced, i.e. a reduction or an enlargement. Scale factors are determined by dividing one corresponding length by the other corresponding length. We did that in the last lesson. In the formula, quantity equals percent of whole. The percent is the scale factor. The whole is the length of the original. The quantity is the length of the scale drawing, always. Okay? And then if two scale factors are given but no lengths, use the scale factors in the formula to find the third scale factor. We'll get to that. That's where the tricky part happens. Okay, so hopefully you can get some information about these things to remember, and we're going to try it. Okay, so new page, changing scales. Please get that title on there. The try it. Find the scale factor as a percent. So here is our little activity that we're going to practice together. Okay. So we have two pockets, okay? This is pocket 1, it's the original. This is pocket 2, it's the drawing, okay? Now, it could have been this is the original and this is the drawing. It doesn't really matter because our job is to find the scale factor for both of them, okay? So if we're looking at pocket 1, let's pretend that pocket 1 is our whole. So we're doing quantity equals percent times whole. We're going to say for this problem right here that pocket 1 will be our whole. So pocket 1 has one dimension that we know of 1.6 inches. The quantity is the scale drawing size. So we don't know the percent. That's what we're trying to figure out. But we do know the scale drawing, and it says 3 36 hundredths inches. Okay? So our job is find the scale factor from pocket 1. So you're starting at pocket 1 to pocket 2. So we're starting. We're ending up here. That's why we chose pocket 1 as the whole. Again, using your information that you know, going back to our BU chart and working with equations. Variable is r. We multiplied it by 1.6, so we have to divide it by 1.6, and we get r. So we're dividing by 1 6/10 on both sides. When you divide 1 6/10 by 1 6/10, you get 1. 1 times r is r. So we have r equals, and now we have to do some math. So we have 3 36 hundredths divided by 1 6/10. So we have to change that, right? We have to multiply this side by 10. What you do to one side, you have to do to the other. So now we have 16 goes into 33 6/10. Okay, now we're pretty good. 16 goes into 33 2 times. So that's 32. And then we subtract and we get 1 left over, bring down our 6. 16 goes into 6 1 time. And now we have found what r is. So r equals 2.1, but we're remembering that r is supposed to be a percent. So I have to take 2.1 and I have to multiply it by 100. So I have 0, 0, 1, and 2 go over 1. So now I know that my scale factor is 210%. Okay? So to go from pocket 1 to pocket 2, I had to increase the size by 210%. Okay? Makes sense. This one's little, this one's big, so it's an enlargement. Your percent is bigger than 100, so you know that it's an enlargement. Okay? Well, now let's try it the other way. It says this time that we need to find the scale factor from pocket 2, so pocket 2 is our whole, to pocket 1, so that's our quantity. So again, using our handy dandy formula that we have literally used for everything. So pocket 2 is the whole this time, so 3 and 3/600 inches. Scale factor we don't know. We're trying to find it if the pocket 1 is 1 and 6/10. Okay, again, equation work, build an undo chart. I have R. I multiplied it by 3 and 3/600, so I'm going to divide by 3 and 3/600, and I should be left with R. Divide this side by 3 and 3/600, I get 1, so I'm left with R, because 1 times R is R. Divide this side by 3 and 3/600, I've got to do some math. So I have 3 and 3/600 goes into 1 and 6/10. I need to multiply by 100 to get this over here, so I have to multiply this by 100. So I end up with 336 goes into 160. Okay, so let's keep going. Long division, our favorite thing in the world. 336 cannot go into 1, 16, or 116 evenly, so we put zeros up there. All right, can it go into 1600? I don't know, let's try. Let's try 5, okay, because 5 times 3 is 15, so that's close. Let's see what happens. So we get 30, regroup, that's 15, 16, 17, 18, regroup. Oh, just too much. Check it out. Okay, so now let's try 4. So 24, regroup, that's 12, 13, 14, regroup, that's 12, 13. So we get 1344. That'll work. So we put the 4 up there, 1344. We subtract, and we get 6, 5, and 2. And that can't go in, so we have to bring down another 0. So now we have 2500, so let's try 8. Okay, 48, regroup the 4, that's 24, 25, 26, 27, 28. Regroup, that's 24, 25, 26, just too much. So now let's try 7. 42, regroup, 21, 22, 23, 24, 25, regroup, 21, 22, 23, that'll work. So we get 7, so we have 23, 52, subtract, that's an 8, that's a 0, that's a 2, still too small, bring down another 0. These guys are all too big. We know that 5 is 680, so let's try 6. So that's 36, regroup, that's 18, 19, 20, 21, that's 18, 19, 20, and we get that, so that's going to be a 6, so we get 2016. Oh, that's kind of funny, our date, isn't it? Okay. All right, so then this one, 3 times would be too big, so this number is going to be a 2. Okay, so I'm going to stop right there because I have so far this. If I multiply this by 100, then I am going to get 46.62%. So if that's my percentage, what would I say that it is? I would say to go from the big one to the little one, it is 47.62%, which could also be known as 48%. It makes sense because it's less than 100, so it's a reduction. Okay, so not too bad, right? You start with the information that you're given. You keep the formula that we're using to find the percent. The percent that you find tells you what kind of scale drawing it is. So let's go back to our goal. Our goal for today was, today we will learn how to determine the scale factor from one drawing to another, which we did 2 times. Can you use a ratio to determine the scale factor? That's exactly what we did. Okay? All right, my dears, that's it for this lesson. It's a lot of math, long division, which I know we all don't love, but we have to try it. So I'll see you all tomorrow. Bye.